Welcome to my channel, platform where I turn struggling math students into maths masters. I post videos every Tuesday and Thursday, so be sure to subscribe and turn on the bell to get notified when I post any videos. Okay, so in this video, I'm going to be teaching you about percentages and really to make sure that you are able to accurately do any type of percentage question that you are asked in an examination. Alright, so let's do this. Alright, so let's look at percentages. Now again, I know that this is not really, an aspect where a lot of people struggle with, but I wanted to make this video because just in case you are having issues with percentages, I think this video will be very helpful. But also, I have not seen a matric final exam paper without percentage questions. So it is definitely a section that's covered, and I know that, it's really covered in grade 10 and earlier years, even in grade 8 and grade 9. But if you didn't get it then it's so easy to make mistakes. So if you struggle with this, or if you just want to sort of make sure that you're doing this and doing this work accurately, then this video is for you. All right. So we're going to start off by just looking at sort of the basic percentage calculations, okay? So I want you to remember two aspects. One, you will either be given a percentage in a question and then asked to use the percentage to find the answer, or you will be asked to actually calculate the percentage, right? So these are two different scenarios. And in the one scenario where you are given the percentage, your calculation will always include a divide by 100. And if you are asked to calculate the percentage, your answer will always have multiplied by 100. So that's where we'll start, because that sort of gives us a gist of how we're going to interpret all of the questions. Okay? So again, if you are given a percentage, you divide by 100. If you are asked to calculate the percentage, then it's multiplied by 100. So let's just look at two basic examples. So question type 1A. 28 out of 35 students are 17 years old. What percentage of students are then 17 years old? Okay, so again, this is simple. This question is asking you for the percentage. So you know you have to multiply by 100. So the way you will do this is you'll just say the 28 over the 35. Okay, so the total amount of students is at the bottom, is in the denominator. So you'll have 28 divided by 35 multiplied by 100. Why? Because they're asking the percentage, and that will give you 80%. Okay? Fairly simple. Now we're going to look at another question that is similar to this. It's the same question, okay? Or from the same context, but just look at what this is being asked, what you're being asked here. So it says, what percentage of students in question type 1 are not 17 years old? Okay, so in the previous question in type 1A, how many are not? Right? So if you look, if 28 out of 35 are 17 years old, then that means the rest of them, right, which is 7 students, are not 17 years old. So you'll say that divided by the total amount of students, which will give you 20. What I want you to take note here is that the total amount of students in this situation is 35. And that 35, which is the total, represents 100%. So 28, which is the 17-year-olds, plus the 7, which is not the students who are not 17 years old. Together, these will make up the 35, and the 35 is then 100%. So these two percentages must add up to 100. Another quick way that you could have answered the second question is, if you're getting 80% in the first question, the second question is asking basically for the rest of them. Now, the rest of them will be the rest of the percentage that would actually make the 100%, which would mean you could have just taken the 100% and multiplied it by and subtracted the 80%, and that would then also give you 20%. Okay, so this is the basic percentage calculations. I'm pretty sure that you guys have this, but I just wanted to make sure that you understand the difference between when you're being asked a percentage and when you're being given a percentage. Okay, so in this case, you were being asked a percentage. So in both of my calculations, I multiply by 100. Now let's look at where we would divide by 100. So in this case, if you read the question, it says 80% of the players in a rugby team. Okay, so clearly that's a typo. So 80% of the players in a rugby team are 19 years old, right? If the team is made up of 15 players, how many players are not 19 years old? Okay, so very similar question, but take note here. 80% are 19 years old. So this is a different question now. Okay, so 80% of the rugby team are 19 years old, right? So they want to know, so how many are not? And if there are 15 players, then how many of the 15 players are then not 19 years old? So that's the question. Now again, you are given the percentage, so you are going to be dividing by 100. But why have I chosen 20? I've chosen 20 because they have given us that 80% are 19 years old. And the question wants to know how many are not 19 years old. So I took the 20. But now I divided by 100, multiplied by the amount of kids there are in a team, and it would give me 3 players. Okay, so again, this slide was really just to show you the difference between when I divide and when I multiply by 100. Okay, because that is sort of the basis that you need to know for all other percentage calculations that we're going to be looking at in the next few slides. Okay, let's move on to the next one. So how do you add and subtract percentages? Okay, so let's look at adding a percentage. So in this case, what would a question look like? Now again, you must remember in Maths Lit, they'll give you a whole lot of scenarios, okay? And you have to interpret the scenario so that you know what calculation to do. So I have literally am just showing you how to do the actual calculations, okay? At the end of this lesson, I will include an example where you can sort of see how we can use the context to actually know what you're calculating. But essentially, I'm just showing you how to do the calculation. So when you're adding a percentage, the question says add 66% to 150. Okay, so you want to have 150, and then you want to add the 66 divided by 100 because there's a percentage in the question, multiply by 150. All right, so if I add these together, so this is the original 150 from the question, plus, and now 66% of 150, and of is obviously multiplication, would then give you the second section. And together this will add up to 249. So 150 plus 66% equals 249. Okay, now let's have a look at subtracting a percentage. Very similar, it's literally just a subtraction sign in the calculation. So in this case, you're going to say subtract 33 1/3 from 150, which means you're going to start off with 150 and you're going to subtract 33 1/3 divided by 100 because the percentage is given, multiply by 150. So again, this second section is what the percentage that we're actually subtracting from the original value. Okay, and then this answer will give you 100. Now please be careful to make sure that you type this correctly in your calculator, especially the mixed fraction in a fraction. Let me know in the comment section if you would like me to show you how to do this on the calculator. Otherwise, you can check it now and make sure that you're getting the correct answer and make sure that you get 100 so that you know that you are using your calculator correctly. Okay, so adding and subtracting percentages, this is how you are going to do it. The next one is calculating the percentage increase and decrease. Now, in the previous section, you'll see that you were given the original value and you were asked to add a percentage. So in this next section we're going to be looking at is we have the starting value and the end value, but we want to find out what percentage was actually added or what percentage was actually subtracted. Okay, so the way you're going to do this, now I've got two examples, one for percentage increase and one for percentage decrease to obviously show you how to do this calculation. But essentially it works as follows. The starting value and the ending value. So what do I mean by that? It's like if you read this example, it says I buy an item for 800 Rand and I sell it for 1,200 Rand. So whatever value came first. So I first bought it for 800 Rand minus 1,200 Rand. So if you're going to do this calculation, you're going to start off with a fraction, and on top of the fraction, you are first going to calculate what is the monetary difference between these two values. Okay, so you'll have 1,200 minus 800. Okay, now where students are not sure on how to do this calculation is the denominator, because they're not sure, do we put 800 Rand as the denominator or do we put 1,200 Rand? So I want to give you a trick on how to figure this out. It's as simple as whichever value came first in the scenario. So I first bought this for 800 Rand and then I sold it for 1,200 Rand. So whatever comes first goes in your denominator. So numerator is always the difference between the two values divided by the original value, right? And that you will then multiply by 100 because we are asked to calculate the percentage. And then we have 50%. So what does that mean? That means that 800 Rand was increased by 50% to get 1,200. Let's look at percentage decrease now. So again, the original price of an item was 1,500 Rand. It has been marked down to 1,200 Rand. What is the percentage decrease? So again, we always start with calculating the difference between the two, and then in the denominator we write down whichever value came first. So in this case, it says the original price of an item was 1,500, so that's the value that comes first. So how do I do this calculation? I say 1,500 minus 1,200 divided by the 1,500. Why? Because that's the value that came first. And then multiplied by 100 because they're asking you to calculate the percentage. And voila, your answer is 20%. So again, what does this 20% mean? It means I took 1,500 minus 20% would then equal the 1,200. Okay, so that is how you would do percentage increase and percentage decrease. Okay, then the last sort of section we're going to look at, and this is the section that is most commonly tested in grade 12 because it's sort of not the most clear-cut or simple way to do this calculation. Okay, so the scenario for these calculations is you have increased a specific value or decreased a specific value by a percentage and you have the answer. But now they give you the percentage and they give you the answer, but they want you to calculate the original value. Okay, so let's have a look how this works. So we'll have a percentage that was added. Okay, so let's have a look here. 15% was added to a cost price to get a selling price of 17,250. Calculate the cost price. So in the previous scenarios type of way of thinking, it means what was the original cost? What was the original value? What was the cost price? Now, please remember not to, because this is what most students do. They take the value and they subtract the 15%. Okay? But that 15% was not calculated on this the after value. It was calculated on the before value. Okay? So you can't say 15% of 17,250 and then subtract that to get the original value. The way you're going to do this is as follows. You are going to say, take the value and you are going to divide it by 1 point and whatever the percentage was. Okay? Now, why 1.15? So, if you think of the original value as 100%, okay? So, we will think of it as this 1 in essence, 100%. Then, the value that comes after this will then be the value that was given. So you were then going to say 17250 divided by 1.15 because the original value represents the 1 and the 0.15 represents the percentage that was added, and then the numerator is then whatever the answer was of that. So to find the original value, you're then going to take your end value and divide your second value, like after the percentage, and then divide it by 1.15, right? And in this case, the answer is 15,000. Okay, so again, I didn't subtract 15%. Okay, now let's have a look at when a percentage has been subtracted. Okay, so 15% was subtracted from a value to get a selling price of 17250. Calculate the original value. Okay, now, if my original value represents 100%, so it represents the 1. But now remember this, from this 1, I've subtracted 15% to get the 17250. So my denominator then will be the 1 minus the 0.15, which then gives you the 0.85. Okay, so I'm taking again my n value. So notice in both of these situations, the n value is always the numerator. Then the denominator would be, what does this n value actually represent? So in the first example, it represented the 100% plus the 15%. That gave me the 1.15. And in this example, this was the 100, it represented the 100% minus the 15%. And that will give you the 0.85. Okay, and this should not be multiplied by 150. Okay, so let me just quickly make sure that I have the right answer here. Please ignore the multiply by 150. So the answer is correct, but just ignore the multiply by 150. Okay, actually, if you give me a moment, I'm actually going to change it now so that, you know, I don't want to confuse you or teach you anything that is not correct. All right. Thank you. Okay, so let's continue from the slide. I'm going to just swap this quickly. All right. So there you go. So that's how you got to the second answer. Okay, so let's quickly recap before we do an example. At the beginning, we looked at if the question has a percentage in it, then that means my calculation will always have a divide by 100 in the calculation. If you are being asked to calculate a percentage, then that means you're going to multiply by 100, right? Then we looked at just the basic calculations, and we looked at adding a percentage, we looked at subtracting a percentage, right? And then we also looked at if you are given the start and the end value, how to calculate the percentage in between. And then now this slide is how do you calculate the original value. So whenever you're reading a question, ask yourself, what is this question actually asking me? It has to be one of these methods that's shown in the slide. And so you will definitely be using one of this. But it's important for you to be able to identify which one so that you are able to use the correct method. Okay, so let's look at an example. So this is more or less what you can expect or how they would possibly ask you questions. Okay, so this is a graph, and on the graph it says religious beliefs in a class of 30. So this is 30 students, and this is the different religious beliefs that they have. The one group is a group of Christians, would be the blue, which is the 35%. Then we have Muslims, which is the 31%. And then we have Buddhists, where the percentage is not given. And then we have non-believers, which is 12%. So this is the religious beliefs in a class of 30. Now let's look at different questions and try and identify which of the sections that we've looked at is this calculation actually part of. So the first one says, what percentage of the class are Buddhists? Okay. So if you remember in the beginning, I told you that the entire class represents 100%. So if I want to calculate how many in the class are Buddhists, then all I'll do is I'll take the 100% and I'll subtract all the percentages that is given in the graph. And that would give me 22%. So what does that mean? That means that 22% of the students, 22% of the 30 students, religious beliefs is of a Buddhist nature. Okay. Next question. how many Christian students are there in this class? Now, see, how many Christians is the amount of students, and what are you given? You are given in a table the percentage. So you know that this is going to be a divide by 100 question. Okay, so you're going to say 35 divided by 100, multiply by the total amount of students in the class, and that would then give you 10.5. Okay, now obviously, remember, if you looked at my previous video on rounding, I explained to you how this question would then have to be rounded down, because context of the question, we are looking at human beings in a classroom, so we cannot get a 0.5 person. Okay, so the amount of whole human beings that are Christians would then be 10. Okay, next one. So there are 10% more Muslims in this class than there was last year. How many Muslims were in the class last year? Okay, so let's quickly break this question down. So there were 10% more Muslims in this class than in the last class. So you know that the last class had 10% less. Okay, so the way you would do this calculation is you will say, okay, first let's calculate how many Muslims are there in this current class. Okay, so we've got 31 divided by 100 multiplied by 30, okay, because you are given the percentage, and that will give you 9 students. Okay, now there were 10%, what do they say? There are 10% more in this class, which means in the last one, there were 10% less. Okay, so how would we do this calculation? So again, we want to know how many was in the original class, right? So if I look at the original class, they had, so remember the original class now represents the 100%, okay? And in this year, there was 10% more. So I'm going to take the end value and divide it by the 1.1 to get an answer of 8 students. Okay, so in the previous class, there were 8 students who were Muslims. Okay, and in this year, there were 9. And that means that there was an increase in 10%. Okay, so do you see how I broke down? I've looked at, okay, what are they asking? What are they giving me? And then based on my knowledge now of how to do all the different calculations, I was then able to answer this question. All right, so I hope this really helped you. I hope that you'll be able to nail your percentages questions. And yeah, thanks so much for watching. Bye-bye. So that's that video. If you liked it, please give it a thumbs up. And yeah, if you have any requests for any future videos, please share that in the comment section. And yeah, I will see you in the next video. Have a good day. Bye.